I'm stuck on a Eurovision live camera. We're going to try and go back live to Antwerp and Professor Wim van den Bergh. Wim, can you hear me?
Yes, I can hear you. This is Antwerp calling. Can you hear me? Yeah, okay. Okay, thank you very much, Mark, also for stepping in, and Ian for the introduction. I hope you can see my screen.
Yes, we can.
Yes, we can.
Okay, good. Good. So I'm also I want to get the award of the longest title for today, also for my presentation. So I would like to give some introduction about the IT that we use in Flanders to improve the quality of asphalt and to deliver input for building information modeling systems and management systems. So for today, I would like to link sustainability to data-driven road management and some research work that we also have. And I want to apply it with a road IT project that we did a couple of years ago in Flanders. So about sustainability, first of all, for our university, for our country, the challenge is for the 21st century that we have to get a shift from durability and towards sustainability for binders, but also for asphalt materials and road structures. I take here the definition for a sustainable pavement. I won't go into detail, but I learned since a couple of years ago that sustainability, if we want to take a look at it, is context sensitive. So the approach that we have to take is not a universal one. There is no standard for it, but it is rather unique for each pavement application. So that means that this context sensitive things is that we have to look at all the materials and all the processes, also the use phase and the reuse, to get any value for sustainability and to compare different materials, processes, and purposes. So what are we aiming to? We are aiming to, about this sustainability, to the use of less new materials. So we want to recycle other materials. We want to use other materials from other flows. We want to optimize our transport, so to decrease the distances, for instance. We want to consume less energy in our processes, also for the transport, and we want to improve quality. And this was our first step that we took in Flanders. We want to use IT to improve the quality. In other steps, in other projects, which I don't mention in this presentation today, we also optimize the transports and also use less energy. Now, as you know, we have already some guidelines available, European ones, international ones. We got some tools also to compare the processes and the materials, but still there is not a final answer if we want to compare materials, road structure in a sustainability context. And we also learned that we as a road engineer, we can't do it on our own. And it's more a multi or an interdisciplinary and very complicated approach if we want to, at the end, have a sustainability assessment. So which are our sustainability challenges that we have? We have some barriers to be solved. For instance, it's also a big discussion in our country. Which parameters have the highest impact on sustainability? Or should we take them all into account? Yeah. If we have to take them all into account, that means that we have a lot of data which we need and we have to use also. Maybe we can have a selection. That is also in part of the LCA and LCCA studies. You can select one or more or all of them. So also these parameters, are they the initial parameters? Is there anything about the circularity also? And also the variability of these parameters should be checked in time. There is also for us a time urgency, because the data that we have today can be used in 10 or 50 years. And I mean then the data from the road, because a road, we don't construct it for 1 year or for 5 years, but we construct it for 10 years or even for 50 years, some of the layers. So that means that if we need the ability to model something, that we need some data from the past, historical data. Unfortunately, it's not there yet. So we have to build this data system from scratch. And then we also need this discussion. Which parameters do we have to take into account for this data? Also, the other barrier that we have is the management of all data. Who will manage all the data? Is it for a road? Is it only for a contractor? Is it for a region? Is it for the whole country? So these are the discussions that we are doing right away. The preliminary needs that we have now is that we need some tools to optimize that, to manage this data, also to see the trends out of it. Maybe if you use a certain type of aggregate, maybe it gives an improvement to the road in certain conditions. If we don't have the data, we don't see trends. Now, also, the acceleration is needed in this implementation process, because I started my career 25 years ago already with these ideas, and still there is no system available for the moment. So it is very urgent to start this implementation process so that we can get the data. And which are the technology that we want to use? It is the BIM environment, of course, the conditions. So we need some digital data acquisition. It is already feasible, only we have to start with it. Then with this data, we can use the machine learning and the neural networks. You probably heard about it, that we can see some trends. The possibilities which we can do then is that we have some actual adjustments in the processes. You can actively change processes, for instance, during the compaction, during the laying process, and so on. We can also, with this data, we can also detect the trends. We can optimize the use of the materials, also optimize the processes, track and trace systems, for instance. I'll give some examples later. Predictions, modeling, improved performance model systems. Also, you can connect it with health and environmental impact that you have when you need a decision right away on the construction site. There are some tools who can help you, can support you based on this historical data. This is our objective that we want to do. And as I said, the first step that we did was in 2015, together with the university, together with some academic partners, and also with a lot of partners from industry. It was a very nice project. It was Road IT. And I will give you some examples of the first steps that we took that time, and also the implementation. In this first project that we did, we had 4 case studies to demonstrate. It's very important to demonstrate your new technologies to industry, because otherwise they won't use it, or everybody is looking to each other who shall start with it. So we did it with the whole industry, and we had these 4 case studies. The first case study was the track and trace system. So we wanted to connect the asphalt plant also with the technical sheets of the asphalt, which was produced that time. We want to connect it with the transport, which is a truck, of course, and also to the finisher. So this gives us the possibility later to track and trace the asphalt which was laid at the construction site. If something went wrong, for instance, in the production site, or during the transport, also waiting times, then at least we know which truck or which asphalt was laid at a certain position, because it was all supported by GPS. Now, we started this project not from the intention to see the problems or to see errors in the whole process, but also to find out success stories. Because you can also use this system as a contractor to show that the quality of your asphalt, or at least your process, your laying process, your production process, is of a high quality. It gives you an advance to other contractors, maybe. A second case study that we did was the use of the infrared line scanner, so that we can detect, that we can measure the temperature. Temperature is very important for the compaction of asphalt, as you know, so that we can monitor this the temperature, and if necessary, that we could start compaction process a little bit earlier at the spots where the asphalt was maybe a little bit colder. We had some examples of that. A third case was the digital reporting. So we want to use all the data that we got during the process in an as-built plan. It's kind of BIM, a building information model. So we wanted to add it to the as-built plan. So for in future, if we need some early cracking, early leveling, or we can compare different materials and we can select then a more appropriate material that at least we have the data. And then the fourth one was also the data storage. Just some words about the first case, so the optimization logistic process of the asphalt production and the construction. So we didn't invent this technology, we just brought some new technologies together, the track and trace system also, for instance, and it was able for the site manager to check, to track and trace all the trucks. So if it is necessary that the asphalt finisher should decrease velocity, the speed, so that the truck was in time, and not that the asphalt finisher should wait for 15 minutes, because then it was cooling down. And you know, if you have asphalt at a lower temperature, that the quality decreases. So that means that if you got this process right, that you also improve the quality on site. Also technical sheets were added to the data. This is an example of the track and trace. So also every truck was monitored with a QR code, for instance, so that the truck, the start and the end position of each truck was monitored and saved also for the data. This is the second case that we did. It was the monitoring of the temperature after the finisher. So we got also here a lot of data, 25 centimeters squares for with a couple of temperature measurements. So also very interesting afterwards to check if for the whole construction site the temperature was good, or maybe you could find some cold spots. And for instance, if you need to check the quality of asphalt together with the compaction, maybe you could search for the colder spots instead of drilling some cores at random places. It saves time, it saves money also, because you got a report which shows your good work. These are some examples. It's more for academics. You can see a lot of figures here for analysis of all the data. You could also add a smart compaction system. That means that this system allows you to count the number of passes at every spot. It also can give you some density measurements, so you can combine it with the temperature measurements. It's also very interesting here to find weak spots or less compacted spots. I go a little bit further. So the third case was the data reporting of a construction site. So every truck was identified. Also the quantity of asphalt when it was, if it was accepted, if it had the right asphalt on board, and so on. So it gives you some evidence later on that you used the right and the correct type of asphalt, and also the quantities. This is an example of one of the test tracks at our campus site. So we combined all the data of several tests and also the construction process data in a building information model system. And as you can see on the left side, you can see that for the second truck there was a problem, that the temperature of the asphalt was a little bit lower. That was because the truck, he arrived in time, but he had to wait half an hour to put the asphalt in the asphalt finisher. So the asphalt finisher was cooled down, and you can see it immediately. You can't see it with your eyes, but you can see it with your infrared line scanner. So we know where the weakest spots will be on this test track. You can extend this also, the data, with smart compaction systems, test results of falling weight deflections, even sensors you can use for permanent monitoring systems. You can all combine it in one BIM file for a section or for a complete road. I think it's very important also for this to get sufficient data for the trends, as you know, so that we can learn out of it. And nowadays, these road IT systems, they are used by the Port of Antwerp-Bruges, also the Flemish Road Agency and the City of Antwerp. They use these road IT systems as a quality parameter, also to decrease the number of cores drilled. And for instance, their objective is to use all the data so that they get detection of adverse conditions for them, for the very specific loadings, some bad or excellent compositions for asphalt, or the combinations of different layers, because you can also use this system not only for the asphalt, but also for the complete structure. And this will give us and them within a couple of years some advice and support to select better asphalt mixtures, but also processes, temperatures, and so on. We see this data use also for connecting the assistance of personal health and safety on the work. For instance, if the asphalt has a too high temperature, for instance, that the workers are warned, or that the construction site manager is warned. So we are combining it. And you could also add in this data file the impact of bitumen, the type of bitumen, the aging process of bitumen, so that you can use it for modeling the performance of a road. We are, I will go fast. We are now into a road design, a smart asphalt pavement performance response model, using all data that we have from the lab, also during the construction and also in service, because we've got a lot of sensors, so that we can combine it and to use it for the trend spotting in the next years. And we even have a system, or we are developing a system, where we can assign certain asphalt roads after recycling to another asphalt construction site to decrease the transport, for instance, and to optimize the recycling rate. If you have the information, if you have the data, you can optimize mixtures, you can optimize also the transport, and you can even relate it with LCA and LCCA. So to conclude, please, I want you also to think about it, to use data more and more. But if you want to use the data, you also need the tools for it, of course, and you have to start with it as an industry. That means that you can use the data later on also, instead of the historical data of last years or decades. You can use the data on an active way, and you can even take a decision on site if you need other mixtures, if you need another thickness, for instance, because it, there is a model behind it using the data from last years. We also are going towards other layers in the structure. So not only for the asphalt, we can also do it for the base layers, for the subbase, and for the soil, that you have a complete structural design model. And for the bitumen industry, I think it's also important that you give more information, or that you give sufficient information in the data, so that it can also allow us to follow the aging process of the bitumen. Also to use bitumen, to recycle the bitumen in future. Okay, I would like to thank you for having me, of course, for this presentation. And if there are any questions, then I will be happy to answer them.
Thanks, Wim. That's great. Thanks for sticking with us as well. I know how stressful it can be when you get into trying to do a presentation and all of a sudden we can't hear you. But so thanks a lot for that. Yeah, some questions have come through. First one, you spoke about the need to accelerate implementation in terms of data gathering. What do you think can be done to do that?
Well, I think that road agencies or road managers, they should be open for these new technologies. They should try it out. And without trying it out, as I said, everybody is looking to each other because for the contractors, it's not their responsibility to give this data. So for us, it was important to have a dialogue with our road agency to convince them and to convince also some contractors to invest in the system. It is a big investment because if it is not asked for it, then the cost will be very high. So we really advise the road managers to put it in their tenders already, maybe not for an evaluation right away, but that they have to, like in the port of Antwerp, it is part of their tender. But the first years that they used it, they are doing that now for 3 years. It was just for the learning process, so that you get all the data, that you get a very good evaluation on both sides, the contractors, but also the road managers, because there are some errors in it. So you have to, to learn it.
Well, it's interesting you say about the getting the contractors to get involved. Was there any pushback from them? Did you experience any of the contractors saying that they didn't necessarily want this because it's almost like having a spy in the cab?
Yes, of course. That's why we started this road IT project with all the parties around the table. But indeed, the first feeling from the contractors was, oh no, a lot of control of our system. And still, for some contractors, they won't do it because of the investment, but also because they don't know that you can also use this system to show that you're doing a good job. And exactly. if I tell this to the contractors or asphalt producers, that you can also use it to see, okay, I got here 10 construction sites, 10 jobs. Well, 9 of them, they were excellent. I can show it to you. And that is more convincing than putting it back to evaluation, a negative evaluation. Also, in the port of Antwerp, they get a fine when it is really bad, but they got also a bonus when it is very good, and then they have to show it with their evaluation.
That's what brings me to sort of my next point. You spoke about the cost of the systems to get the data. How does that balance up with the potential benefit? Do you think we're far away from a break-even point, or do the costs outweigh the benefits at the moment?
Well, the costs are a couple of percent of the total construction site cost, of course. But I think that at the moment now, it is an investment for everybody, for each party, for the contractors, for the systems, but also for the road manager, because they need to pay it. So they pay for it, of course. But we think that when we got more data, also for the contractors themselves, they could optimize their processes. And they are looking forward to our system where we can assign certain asphalt roads, which are now just a road and has to be milled and reclaimed, for instance. Mm-hmm. If they have the data, okay, without drilling a lot of cores to analyze it, but if they have the information on beforehand, then they have an advance, because they know that with this data, they can recycle more than another contractor because they got the data.
Yeah.
If exactly. You got the information, it is a benefit. And this is something, I'm an academic, so this is for me. But I see that a lot of contractors now, big contractors in Belgium, they are investing in it. So I'm very sure that it will have a benefit for the contractor. Otherwise, they won't do it. Yeah,
I'm sure it will, Wim. And you know, if we can get away from this process of having to do random cores of a new asphalt surface to find out what the potential issues are, then I think that's got to be a positive step. So thank you very much for that and for your time and talking to us today. Another great session.